I am Gautam and my batchmates are Kadirvel, Prabhu and Lokesh. We are doing a project on partial replacement of cement using silica fume and metakaolin. We did the project in the college and the guide was Mr. M. Vignesh Kumar. Now we'll see the abstract. So in the construction industry, mainly the production of Portland cement will cause emission of pollutants, resulting in environmental pollution which is reduced by increasing the usage of industrial byproducts. The industrial byproducts are such as silica fume and metakaolin. Here we carried out various trials using varying percentages of silica fume and metakaolin. This we are calculating their strength by seeing their parameters such as workability and compressive strength. The obtained results will be compared with conventional concrete. The aim of the project. The aim of the project, with environmental concerns stemming from high energy expense and emission of pollutants associated with the cement manufacture, have brought about measures to reduce cement consumption through use of supplementary cementatious material, which offers a considerable strength at a relatively. The objective of the project is to produce high strength concrete using cementatious material, which is silica fume and metakaolin. By adding these materials, we can get an improvement in workability, durability, and strength resistance to cracks. It also reduces the emission of pollutants and it also can increase the lifespan of concrete. The materials we are using is silica fume. As you can see, silica fume is a byproduct which is resulting from coke with the reduction of high purity quartz with coke or coal. The principal effect of silica fume is very fine particle can fit into space which cannot be filled by cement materials. So it has a high content of amorphous silica and the chemical component could be, the next material would be metakaolin. Metakaolin is a pozzolanic material which is manufactured from the selected kaolins, which is highly efficient by acting as a cementatious material. So by adding cement and water, you get a cementatious and a non-cementatious material. Then adding the non-cementatious material with metakaolin produces both cementatious material. And you can see the percentages of silicon dioxide and aluminum trioxide shown below. So this is next we can see is super plasticizer. Here the super plasticizer is what we have used is Complast SP430. Complast SP430 gives a high degree of workability. It also reduces the water cement ratio. The main advantage is it to give improved workability, improved quality and higher cohesion. Next is what we see is the methodology flowchart, where first we have we have collected the literature reviews and we have selected the materials. Then we have done the mixed design ratio accordingly. Then by adding silica fume and metakaolin with varying percentages, we are preparing concrete. The workability of the concrete is found using 7 tests, and then we are casting the cubes, then curing it for 7 days, 14 days and 28 days, then testing them for compressive strength and split tensile strength. Then the graph and calculations are. The experimentation done would be for workability slum test and for strength, compressive strength test and split tensile strength test. Next we have the specific gravity test, which is done by pacnometer. As you can see, the W1, W2, W3 and W4 respectively represents the empty pacnometer, weight of sand plus weight of pacnometer, weight of water plus weight of sand plus weight of pacnometer. The last represents the weight of water plus the empty weight pacnometer. So by calculating this, for coarse aggregate we have found the value of 2.647. Similarly, for fine aggregate we have found as 2.61. These are the specific gravity which is found using the specific gravity. Next, by finding the specific gravity test, we are grading the limits of fine aggregate according to IS 383 of 1970 and which was found to be conforming to zone. Next, we are doing the slump test using the slump form, and we found all the slump values to be found, which was less than 50 mm. Next is the water absorption test, which is done by wetting the coarse aggregate, then drying it, then finding the amount of water absorption in the coarse aggregate and fine aggregate. In coarse aggregate, the water absorption was found to be 0.643%, and similarly, the fine aggregate, it was found to be 1%. So next is the mix design which we have followed. We have used a OPC 43 grade cement, and the specific gravity of cement was 3.15, and specific gravity of silica foam was 2.2, and the specific gravity of metakaolin was 2.5, and the specific gravity of coarse aggregate is 2.65, specific gravity of fine aggregate is 2.61, and the water absorption is as given as 0.643%. Then doing the CV analysis test conforming to zone 2, we got the target strength, and the 1.65 S represents the standard deviation, where S can be 5 according to table 1 of IS 10262. So the maximum value for M40 concrete we have done here should be around 48.25. That is the maximum value which we get from IS. So we are adopting a water cement ratio of 0.4. Then selection of water content, then adding the superplasticizers, then the aggregate and fine aggregate is found. Then the mix is done accordingly. For 1 meter cube of concrete, the volume of cement is taken as 0.1292 meter cube, and volume of water is taken as 0.146, and the chemical admixture is taken as 0.007 meter cube. All these, we have got the mix proportion as 1 is to 1.747 is to 2.91 is to 0.358. Then the table represents the weight batching for 5% of silica fume and 20% of metakaolin. Then we have got the compressive strength, and as you can see, for 0% and 0% of metakaolin, we have got the 7 days, 14 days and 28 days strength, which was found to be 44.62. Then gradually there has been an increase by increasing the silica fume and metakaolin percentage. As you can see, the 25% replacement for, that is silica fume of 5% and metakaolin of 20%. You can see the greatest strength in 28 days, which is found to be 50.27 Newton per mm square. Then you can then see gradual decrease, then again increase. 25% is the maximum amount of replacement, and you get the highest strength there. So this is the compressive strength which is done. Next, you can see for 5% replacement of silica fume and varying percentages of metakaolin, you can see the graph. As you can see, for 25% replacement, there has been a greater increase in the strength. Then next is the 10% replacement of silica fume with varying percentages of metakaolin. There also you can see 25% replacement gives maximum strength value. So as you can see here, for normal concrete, the compressive strength is around 44.62 for 28 days, and for when the silica fume and metakaolin is added, the strength increased is by 4.1012%, and when it's increased to 25%, you can see an increase by 12.67%. With 30% replacement, you can see a decrease. And so we are considering that for silica fume and metakaolin, 25% replacement is the maximum replacement where you can get maximum strength. So this is the split tensile strength we have done in the lab. To the compressive strength, where you can see in the table, the graded value is for 25% replacement here also. So from the graph, you can see the red line 2.952 represents the reference line, and you can see for 25 replacement you have got the maximum strength of 3.77 Newton per mm square, and similarly for 10% of silica fume and varying percentage of metakaolin, there also you can see 25% gives the maximum value results. From these we have obtained the results, that is the 28-day compressive strength concrete generally increases the metakaolin content up to its optimum content, but all the silica fume contents. and therefore it declines. So the 7-day compressive strength of concrete generally decreases with increase in metacolin content at all the silica fume contents. Thus, the optimum dosage should be for 5% and 25%, that is the maximum strength. The slump is found to decrease with increase in metacolin at all the silica fumes. Then we have given the conclusion. The maximum strength is around 25% for replacement. As you can see, the maximum replacement for silica fume is 10%, but in our project 5% is only the maximum replacement. The maximum replacement for metakaolin according to studies is 30%, but we are considering the maximum strength to be 20% only. From the results, the strength is found to be more conventional, more than the conventional concrete. Thus, we are reducing the pollutants and also increasing. These are the references.